And hopefully the recording has started. Okay, so good morning. This is week 4, October 3rd. So the agenda is I'm going to talk about term test 1. It will be held on October 10. Start time is 9 a.m. We will finish exactly at 1. Okay. So the usual schedule for the term test in usual time, we should finish at 2:30, so 11:30. Okay, and if it's face to face. Okay, so you go to McMaster, take the exam, it should end at 11:30. But because it's online, okay, you guys are doing me a favor. I'll give you an extra 1.5 hours to upload your answer. And this extra 1.5 hours, the 1 o'clock deadline is a very hard deadline, okay? So unless there are some issues on your internet, then you have to give me a call. So during the term test, I will log on Teams like this, like usual, okay? And then you do your questions, and the question be distributed on crowd mark. Okay, so you should be able to access crowd mark now. Okay, so everything will be going through crowd mark. Okay, then you review your term test. It's also on crowd mark. Okay, so it's very convenient that way. So I'll give you an example of your term test. What do you expect? So this is like a typical question that you not. So the instruction is on every top page of your answer script, you should write down your first name, followed by your last name, student number, and then question 1, page what? Okay, question 1, page 2, question 1, so on and so forth. Okay. So when you have completed your answers, take images or scan into one single file, PDF it, and submit onto CrowdMark. Okay. I expect it to be clear. Your answer has to be clear, because if I can't read your answer, then it's difficult for me to mark when it's not clear. Okay, so it has to be clear. Now, strongly suggest 80% of the time to attempt the question, 20% of the time put aside to scan and complete your compile your answers. Okay, so this is where the 1.5 hours extra has been given to you to compile your answers. Okay. Now, when I'm on Teams, you don't need to switch on your camera or whatsoever. It's non-proctor. Okay, I'm not going to proctor you. I'm going to trust you. Okay, I'm not going to proctor you. I'm going to trust you that you will be honest. Okay. If you want to discuss, I will not know. I'll tell you straight. Okay, if you're going to open a discussion, fine. Okay, go for it. Okay. I'm not that I'm not bothered, but it takes time to discuss. Okay, I rather spend time to think about the solution. Right. So how does a question work? So this is not the question that you will get. Okay, so this is a structure that you see. So all your question, all of you will receive the same figure. Okay, I want you to take note is this. So over here you see 3B. Over here you see 1A. And over here you see 1C. What does it mean? Okay, so if you look over here, ABC given over here in the question denotes the last 3 digits of your student number. Okay, I can even use the last 4 digits of your student number. Okay, so if your student number over here like is 351, so A is 3, B is 5, C is what? 1. Okay, so 351. Okay, 351. So what you see over here, right? So when you come to this number over here, this load is what? 3b. So b is equal to what? Can someone tell me what is b equal to? Hello? B is equal to what?
5.
5. Yep. So this will be 35. Right? And then over here you have 1a. A is 3. So this is 13 Newton per meter. This is 35 Newton per meter. And then the length is 1c, and this is corresponding to 11 meters. Okay. So I think this way of testing is fair. Okay. The numbers are unique for every one of you. Okay. So this is how the test is going to be. So if you're going to discuss, yep, you decide, but your final answer, the probability of being the same is very low. Okay, I repeat again, the probability the same is very low. Okay, so in your term test, you're going to get 3 questions. Okay, you're going to see 3 questions. Okay, so the question will be from homework 01, homework 02, homework 03, homework 04. Sorry, it's not the question. You have to know how to do homework 1, 2, 3, and 4. And also you have to go to your lecture in week 1, 2, 3, and 4. Right? So anyone, any question? Is this clear? Anyone? If you are not clear, I will explain to you. Anyone? Are you okay? Are you okay? Is it clear or no? Yes, okay. Okay, so this is how is going to be. Okay, so 3 questions. Okay, so as I said, it will be on crop mark. Okay, and then you hand in everything on crop mark, like what you are doing for your quizzes. Now I've done some answers for homework number 3. So if you have so I posted 2 solutions done by myself on homework number 3. If you have any others, just let me know. Okay, and I also will pick, because you guys have not seen homework number 4, I will pick 2 tough questions for homework number 4 and do it online for you. Okay, all right, everyone clear for your term test? Okay, everyone is clear. Good. So what I'm going to do today is we're going to continue on shearing stress example, and then we're going to look at longitudinal shear of a beam section, and then we are going to look at a shearing stress on a beam section. So I will recall quickly. So there's a possibility that today's lecture again will go over time. Okay, just to warn you, we'll take our first break at about between 10:30 to 10:45. I realize when I go to 11, a lot of you are exhausted already. Right. So let's look briefly at last week's example. Okay, I'm not finished yet. So what we were doing is we did something further, right? So this question looked for the shearing stress at point A and point B. So this being point A and that being point B. But we have done further. Okay, we have done more. What do I mean that we have done more? We started forming the shearing stress equation in the flange section. Yes or no? So we have the distribution. So for the flange section, the unique thing about the flange section is the thickness. Now this is equal to 0.16 meter. Okay, so this is from the flange section. Then we did another one for the shearing stress in the top web section. So if we go to this figure over here, we have found our shearing stress in the top web section. Okay, so important thing to take note in the top web section, the first moment of area you have to consider is this entire region. So you have to include the flange and the top web. Okay, and where this line is, so from here to here, our centroid. I think our centroid, we found it. I have to recall what was our centroid. Our centroid is 35 millimeters. Okay, so distance from here to here is 0.035 meters. Right. So this equation over here, or this expression over here, is our first moment of area. Okay, for the top web, right? So next, what I'm going to do is we're going to find the shearing stress of the bottom web section. So before I do anything, I am still going to copy these rules and paste them here. Okay, I'm going to paste them here. It's small, but it is like my help sheet. Okay, it's like my help sheet. So next, we are going to look at, we're going to find the shearing stress. If the question asks the shearing stress of the beam, which area of the beam? Wei Ming, can you speak? In the question, if the question asks the shear stress of the beam, which area of the beam refer to? Wei Ming, so what are you confused about? Is it you take the top or the? I mean, do you take this region? Sorry, probably you don't have a mic. Are you thinking is this region or is it this region or is it this region? Am I right? Yes or no? Yes. Okay. I will go into detail about this. So the right answer is the thickness. You take the smaller thickness, and I'll show you why later on. Okay, that is a very good question. By the way, that's a very good. I can see that you are doing your homework. Okay, I can see that you are doing your homework. That's good. So let me go through this exercise first. Then we'll look into Wei Ming's question regarding which area do we take, and I believe all of you or some of you have that issue, which is good. This is a good problem to have. Okay. So now we are going to find the shearing stress of the bottom web section. So this is where we highlight that this is the region of the bottom web section. So the analysis again will start with the analysis. The datum is at the centroid, and the bottom, this is the analysis direction, right? So this is, sorry. So this is the analysis direction. Right? Why that is the analysis direction? Because we apply rule number 3 that state the analysis will be carried out from y variable that is going to be the what? That's going to be the maximum. So this solution over here, right, will range from 0, x, and sorry, y, okay, not x. So 0, okay, 0, y, and is equal to 0. Up to 0.065. Am I right? 65. So let me see. Is it 6? Yep, 0.065. Why 0.065? Because this entire thickness is 0.1 millimeters. So the height section over here, this is equal to 0.065 meters or 65 millimeters. Okay. So we're going to find the first moment of area. So this is still Q ZZ about the ZZ axis. So it is equal. So this is for the bottom web. And then this expression will be A y bar. So the area, so over here we have to consider the 2, right? So we have to multiply by 2. The 2 down here is because you have left and right web, right? So this is what we call left, and this is our right. Okay. So the width is 0.03. sorry, the width is not 0.03. I got it wrong the last time. Okay, so the width is 0.02. The height now will be equal to 0.065.